Dear students, in this video I will discuss different numericals based on the earthquake resistant structure. It is in semester 7, Mumbai University Architecture course, Theory of Structure 7. I hope you have seen my video on the theory discussed on the earthquake resistant structure. The link is given in the description box. Here we will discuss about the different numericals based on the earthquake resistant structure. So let us have a look at the formulae first. Magnitude of the earthquake M is equal to log 10 within bracket I by S, where I is the intensity or amplitude of the seismograph reading, S is the intensity of the standard earthquake. If it is given in the question, use that value. Otherwise, you are expected to know the value of the standard earthquake intensity, that is 1 micron. And 1 micron is equal to 10 to the power minus 4 centimeter. Number 2. Magnitude of earthquake can also be expressed in terms of the epicentral intensity. Magnitude of earthquake capital M is equal to 2 I0 by 3 or 2/3 I0 plus 1. Here I0 is the epicentral intensity. Point number 3. Seismic moment M0 is equal to dA mu, where D is the average fault displacement or the slip, A is the total area of the fault surface, mu is the average modulus of rigidity. Number 4. Moment magnitude MW is equal to 2/3 of log 10 within bracket M0 minus 10.7. Here M0 is the seismic moment as discussed in step number 3. Number 5. Time taken by a seismic wave T is equal to distance travelled by the wave, that is S, divided by the velocity of the wave V. So T equal to S by V. Before proceeding for the numerical, just a quick recap that these three formulae you should remember about the log. So the first one goes as log A by B is equal to log A minus log B. Formula number 2, log AB is equal to log A plus log B. And point number 3 is log M to the base 10 is equal to N. Then M can be found out as 10 to the power N. Before proceeding for the numerical, one basic definition also you are supposed to know about the MMI scale. So what is the MMI scale in earthquake? MMI full form is the modified Mercalli scale. It was developed to measure the effects of the earthquake on buildings and people. So the scale varies from 1 to 12 and it is written as I have shown you in the slide. In the Roman numerical it is written 1 to 12. So if the Mercalli indexes is 6 or lower than it, then it measures the effect of the earthquake on people. But if it is 7 or higher, that is up to 7, from 7 to 12, it measures the effect of an earthquake on the buildings. Let us have a look at the question number 1. The 1985 Mexico City earthquake had a magnitude of 8.1 on the Richter scale. The 1976 earthquake in Tangshan, China was 1.26 times as intense. What was the magnitude of the Tangshan earthquake? So this problem is based on the first formula as I have mentioned, that is the magnitude of an earthquake is equal to log 10 I by S. Here I is the intensity of the seismograph reading and S is the intensity of the standard earthquake, which we know as the 1 micron or 10 to the power minus 4 centimeter. So the equation number 1, we can write it down for the Mexico City earthquake. The Mexico City earthquake magnitude is given as 8.1. So M is 8.1 and log I by S, where I is the intensity of the Mexico earthquake and S is the standard earthquake. Here I am not putting the value of the S, that is 10 to the power minus 4 centimeter, that we are not putting. We are keeping it just as it is. Only we are putting the value of M, that is 8.1, that is the Mexico City earthquake magnitude. Now let us write down the second equation, the same equation for the China earthquake. So for the China earthquake we have to find out the magnitude of the earthquake. So M is equal to log, now what is the intensity? Intensity of the China earthquake is 1.26 times of the Mexico City earthquake. So if the Mexico City earthquake is I, as I have taken it in equation number 1, so China earthquake will be 1.26 I. So in place of intensity, I have written it as 1.26 I. And S is what? S is the standard earthquake. It will be same for China as well as Mexico. So it doesn't change. Only the I, intensity value changes. So that is our equation number 2. Now here you have to little bit manipulate the equation in such a way so that we can get the answer quickly. So we are taking the value of 1.26 as A. If we assume it as capital A, and I by S as B. So the second equation turns out to be log AB, where A is 1.26 and B is I by S. So log AB is equal to log A plus log B, that is log 1.26 plus log I by S. The intention of doing it is that if we write it in this way, so log I by S value can be found out from equation number 1, that is 8.1. So we can directly put down the value of log I by S equal to 8.1, and we can find out the value of log 1.26 from the calculator. It is 0.1. So the magnitude comes out to be 8.2 for the Tangshan earthquake. This is the problem number 1. Let us have a look at the question number 2. The 1934 earthquake in Bihar, Nepal region had a magnitude of 8.3 on the Richter scale. On 19th March 2020 in Nicobar Islands, an earthquake with magnitude 4.9 caused only minor damage. How many times more intense was the Bihar Nepal earthquake than the Nicobar earthquake? So again we will use the formula number 1, M is equal to log 10 I by S. But here we have to find the ratio between IA by IB. That is the Nepal earthquake intensity and the Nicobar earthquake intensity, the ratio between them. So we can write it like this way, that log IA by IB is equal to log IA by S divided by IB by S. Numerator and denominator both we can divide it by S. We can do the same operation in the numerator and denominator. So now it comes out to be log A by B. So that means log IA by S minus log IB by S. So log IA by S is equal to MA and log IB by S equal to MB. So what is the value of MA? That is the value of the Bihar Nepal region earthquake, that is 8.3. What is the value of the Nicobar island earthquake value? That is 4.9. So 8.3 minus 4.9 gives us to be 3.4. Now log IA by IB equal to 3.4. So IA by IB will be 10 to the power 3.4, which gives us 2511.8. So finally we can approximate and write the value that earthquake of the Bihar was 2500 times as intense of the Nicobar earthquake. Question number 3. The epicentral intensity of an earthquake that occurred in 1870 is estimated to be 9 in MMI scale. Estimate the approximate magnitude of the earthquake. So the magnitude of the earthquake M can be written as 2/3 I0 plus 1, where I0 is the epicentral intensity. So here the epicentral intensity value is given as 9. So equivalent earthquake magnitude will be M is equal to 2/3 into 9 plus 1. That comes out to be 7. Question number 4. Estimate seismic moment and the moment magnitude of an event with rupture length of 100 km, rupture width of 45 km and average fault slip of 3 meter. Take modulus of rigidity mu as 3.5 into 10 raised to 10 Newton per meter square. So here D is the average fault slip, that is 3 meter. Rupture length is 100 km. So convert it into meter, 100 into 10 cube meter. Width is given as 45 km rupture width. So 45 into 10 cube meter. So A is the area of the fault surface, that is L into B. So that comes out to be 45 into 10 raised to 8 meter square. Now the first one is the seismic moment we have to evaluate. That is equal to dA into mu. So D is 3 meter. A value is 45 into 10 raised to 8. and mu is 3.5 into 10 raised to 10. So this gives us to be 472.5 into 10 raised to 18 Newton meter. Now moment magnitude will be mw is equal to 2/3 log m0 minus 10.7. So put the value of m0, that is the seismic moment, in the equation, and we get the value of moment magnitude is equal to 3.08. Question number 5. At a recording station, a difference in time of arrival between P waves and S waves was observed to be 1.5 seconds. What is the approximate distance from the station at which the event occurred? Assume P wave velocity as 4 km per second and S wave velocity as 2 km per second. So velocity of the P wave, let us name it as Vp, as 4000 meter per second. We have converted the kilometer to meter, and velocity of S wave, similarly Vs equal to 2000 meter per second. 2 km equal to 2000 meter. Now difference in time delta t is equal to 1.5 second. These all values are given in the question. Now we have to find the distance from the recording station to the event, that is S. So how we will proceed? First we will find out time for the P wave to travel, that is Tp, is equal to S by Vp. And for S wave it is Ts equal to S by Vs. See, in both the cases the distance covered is same. What is different? The velocity is different, and obviously the time taken is also different, but the distance is same. So difference in time, how we can find it out? Delta t is equal to S by Vs minus S by Vp. So delta t is given as 1.5. So in the left hand side we are putting 1.5, right hand side take S common and take it out of the bracket, and then within bracket it is 1 by Vs minus 1 by Vp. What is the value of Vs? That is 2000. What is the value of Vp? That is 4000. First line and the second line I have written the solution. So S comes out to be, if you solve it, 6000 meter. That means 6 kilometers. So the distance of the recording station to the event is 6 kilometers.